We're here for a special Clean Technica webinar with GridBeyond and an NREL scientist, unlocking the value of virtual power plants. Should be a really exciting, I think, fascinating topic today. Virtual power plants are sort of like the hot topic of the past couple of years, but we've got some true experts here who are diving into it in a deeper way than we've ever done before. And I think sometimes in some ways a more interesting way. So let me first introduce who's with us today, and then they'll talk a little bit more about their background before we get into the questions. So we have Andrey Bernstein, Senior Research Manager at National Renewable Energy Laboratory, NREL. We have Jeremy Cook, who's the Director of Net Zero Solutions at GridBeyond, and Ben Sigrin, Senior Product Manager at GridBeyond. So I'll give a short bio, and then afterwards would love to hear a little bit more from each of you on how you got into this topic, how you got into this field, and then we'll go from there. So Andrey Bernstein has been the Senior Principal Researcher and Group Manager at the National Renewable Energy Laboratory since 2016. His research interests are in the decision and control problems in complex environments and machine learning methods with application to power and energy systems. Jeremy Cook is Director of Net Zero Solutions at GridBeyond, a leading provider of AI, machine learning powered solutions for distributed energy resources. He has over 15 years of experience in the energy and sustainability sector. Jeremy is a passionate net zero warrior with a deep understanding of the energy transition landscape. And Ben Sigrin is Senior Product Manager at GridBeyond, where he leads development of software products that forecast, optimize, and control flexibility services in real time. He is also the principal investigator of a recent competitively solicited Department of Energy award to deploy GridBeyond's software platform. Mr. Sigrin was previously a senior researcher at NREL, where Andrey is, where he participated in seminal power system studies. And I am Zachary Shahan, CEO of Clean Technica. I've been running Clean Technica for 15 years, almost 15 years, and we believe we're the premier global clean tech news and analysis site. We cover globally relevant topics much more than a lot of others, and I mean, we've been talking about these topics for years, so it's always a case of what's new, but also how do we introduce people new to the topic to this field. So let's start with Andrey. Can you just explain a little bit further how you got into this field and into NREL and virtual power plants specifically?
Yeah, thanks for the introduction, Zach. I think, yeah, it's a pleasure to be here and talk about virtual power plants. I think virtual power plants is really a hot topic right now, but I think we started thinking about them really a long time ago. So my background, I can start from my background. My background is more in the mathematical optimization, machine learning. And I got into power systems maybe 10, 12 years ago with the idea of trying to apply all these fancy optimization approaches in the future power systems with the high penetration of distributed energy resources and renewable energy. So yeah, and that's kind of where it all started. But as we went forward, and I think, again, quite a long time ago, we realized that eventually you would like to have something like virtual power plants implemented in the future grids, where you take all these millions of devices that will be deployed in the future network, such as smart appliances, solar panels, electric vehicle batteries, and all this stuff, and you want to create a power plant out of them that would act as a real power plant. It could be dispatched to a certain power set point. It could provide services to the overall grid, and it could also essentially, beat into market in the energy market eventually. So how do you do that? That was the main question. How do you coordinate? How do you implement this vision where you have millions of devices? You want to aggregate them, let's say in a physical location, maybe a neighborhood or a city level, depending that the scale could be different. And how do you coordinate all these millions of devices in real time to eventually implement something that works like a power plant, right? Something that can change its power, its aggregate power generation or consumption. So this power plant essentially could be bidirectional. Essentially, it's a battery. It's not necessarily a power plant. But how do you do that in real time? How do you scale to very large systems where you have a lot of devices that you need to control on the edge, you know, in a distribution level? So
I think you'll get to that in a presentation in a moment that will help you know, further explain that.
Right.
But yeah, sounds great. Jeremy, what's your background? What led you into GridBeyond and then also into virtual power plants?
Yeah, thanks, Zach. Yeah, so what led me, my background is, like you mentioned, I got about 15 years of experience promoting sustainable design, really kind of looking to accelerate progress towards a more sustainable future. I left ENGIE, the world's largest independent power producer, to join GridBeyond, really out of a fascination of their AI and machine learning technologies and how that can be utilized to accelerate progress towards a more decarbonized energy future. I lead the commercial team, so you know Andrey and Ben are the smart guys in the room. Really, what I'll offer today in the webinar is kind of the commercial perspective. I'm having the conversations with our clients and customers. I'm joining here today from San Jose, where I'll be attending the Verge conference. So this is a great primer conversation for the conference this week, where virtual power plants are a hot topic at the conference. I think everybody's interested in how can we utilize virtual power plants to help accelerate the investment in distributed energy resources and also help utilities and grid operators overcome some of the challenges with the massive load that's coming through electrification. So with that, back to you, Zach.
Yeah, thanks for not putting me in the smart guys bucket, Jeremy. I'm just no, it's yeah, there's so much to dive into here. So there's so many angles of virtual power plants. There's one like a soft angle I'm going to get to after Ben's intro that I'm just curious if anyone has background knowledge on. But yeah, let's move on to Ben. Ben, what's your background? How did you get into GridBeyond, and then how did you also get into the virtual power plant topic more specifically?
Yeah, thanks, Zach. I've been in energy, clean energy most of my career. I don't know if I can introduce virtual power plants any better than Andrey did, but you know, my interest in clean energy started from wanting to make an impact on the world and also being able to apply it in a quantitative way. I've actually always been interested in distributed energy resources. There's an aspect of that democratization that's always fascinated me, consumers being able to control their own energy future. And then I think if you pair that with the growth of digital technologies, both machine learning, but also just kind of basic communications and IT platforms, I think you unlock something really special where you have distributed power generation that's able to communicate, as Andrey said, up to 10,000s, millions of devices simultaneously. So that's just always fascinated me. At GridBeyond, we are forecasting optimization control shop. So we provide our own virtual power plants in Ireland and are expanding them in the United States. And so we use our hardware and software solutions to enable our end users to unlock more value out of their resources.
Excellent. Yeah. I know nobody signed up for a pop quiz, but it just came to mind. Does anyone know who coined the term virtual power plants? I do not. So it's not a pop quiz because I don't have an answer, but I'm just curious if anyone knows. It's not been that long around when Andrey was talking about it, and even when Ben was talking about distributed energy systems and democratized energy solutions, you know, it just came to mind like this idea is not fundamentally that new, but the term virtual power plants has just been really used the past few years quite a lot. So I don't know if anyone had the background on that. Sounds like you do not. Let's go back to just explaining what it is again. I agree, Andrey did a superb job of kind of giving a summary explanation of what a virtual power plant is, but I know he can do better. So back at you, Ben. Sorry, at Andrey. No, Ben was going to give more of a okay. So. But you have a slideshow as well. Is that going to come after yours?
I will figure it out. Yeah, not maybe. Let's first let Ben to.
Okay. All right. Well, Ben, you said you can't do it better, so let's see if you can try.
Well, I think you hinted at. I'm unfortunately I'm not going to pass the pop quiz, but I think you hinted at sort of the premise and the peril of DERs, where you potentially have millions of independently operated resources that are all acting on their own set of incentives and cost functions. And I think the premise of a virtual power plant is to provide order from that potential chaos. So I think in a very basic sense, a virtual power plant is just a network of decentralized small to medium large power generation or consumption devices. So think of rooftop solar, battery energy storage, electric vehicles, smart thermostats, other smart appliances. We're aggregating them together to act in a unified way. They are each of them their own individual device, but they're acting in concert. The sum is larger than the individual pieces. And I think one of the really key insights here is that this aggregation allows a virtual power plant to provide both utility scale and utility grade grid services. So independent DERs are unlikely to be able to provide those types of services to the grid, but acting in concert, they can provide energy capacity and ancillary services to the grid. So this allows us to maintain the stability of the grid and is especially important when we think about increasing shares of variable, intermittent, renewable resources like wind, solar, and storage. So the other kind of aspect I'd bring in here is talking about the economic aspect. So it's providing a clear set of price signals and reward functions to the DERs, so they're acting in an aligned way. It also provides a very welcome source of revenue for DER owners, whether that's residential, commercial, or industrial users. It allows them to unlock their access to participate in energy trading, as well as any other ancillary services or grid services they can provide.
Yeah, great stuff. Great intro. And I think all of you have been around long enough that you know there was a lot of claim that we needed baseload power. If we switched to solar and wind energy, we wouldn't have the baseload power we need. We had many articles, some really superb ones over the years, explaining why that's a myth, why that's not really the case, why baseload power has its own drawbacks. But virtual power plants sort of step in as a kind of baseload power for the grid. Can you explain more, Andrey? Sorry. Why VPPs are important?
Yeah, I think, yeah, some of the points were mentioned already by Ben and Jeremy so far, but I think, first of all, if we think about clean energy goals, right, I think in my mind, virtual power plants is an essential building block to implement the clean energy future, because we talk a lot about decarbonizing the system and then removing the reliance on the carbon driven power plants, right, or other power plants that may be polluting the atmosphere. But yeah, in order to implement this, you need to replace this power plant with something else, right? And this something else, in our mind, I think it could be a consensus here, is one of the building blocks is the virtual power plants, right? So that's kind of, I guess, trivial, but I just wanted to point it out, right? So if you're trying to replace a big power plant with something else, the virtual power plant that aggregates millions of devices could represent some part of this new future with less power plants dependent on fuel. I think the other part here that is kind of connecting in my mind the customer side of things is really that virtual power plants allows to actively coordinate end customer and utility scale devices to provide services to the grid. So essentially you are connecting in virtual power plant, you're connecting the customers to the grid in a more active way, in a sense that they can provide collectively, but individually, everyone, these services, and maybe also get compensated for this as well through some market mechanisms and so on. So basically it provides value both to the customers and utilities eventually, the virtual power plant concept. And the other thing I wanted to point out before I let others to speak is is also the fact that virtual power plant by itself is also, as I mentioned, a building block for future grid in our mind. And another related concepts is microgrids, right? So basically, a virtual power plant, when it is connected to the network, it's a power plant. But in the view of the higher level network, right? But internally, the virtual power plant itself could also act as a microgrid, whatever needed, whenever there is no higher level grid, right? If something happened, there is a contingency, there is I don't know, a hurricane or another natural event. If you design virtual power plant well, it will be able to operate by itself and sustain at least some of the critical load within the system of the virtual power plant. So I think that's another concept that I wanted to bring up here as part of virtual power plant that contributes to resilience and survivability of the grid in the future.
Yeah, and we have another question for you, Andrey, but if anyone else wants to chime in first on why VPPs are important, do you want to step in, or we move on?
Yeah, well, I think, also, Zach, you talked about baseload power at the beginning, and I think that, we think about the benefits of baseload power, firm, dispatchable, predictable power, sort of the bedrock of our generation stack. But there's also, traditionally negative trade-offs, both in terms of environmental, but operational flexibility. If you have a large nuclear power plant that's providing baseload power, it cannot easily ramp up and down quickly to accommodate changes in, say, variable generation. So I think that virtual power plants done well actually can capture both sides of the coin. They can smooth out and provide that firm dispatchable power by virtue of aggregating these millions of individual small resources, but as well as providing traditionally clean power and something that is very, very flexible because it's composed of these millions of different building blocks together.
Yeah, I think that's a really key thing to highlight because, like you said, there's a big flexibility problem with baseload power. That's one of the things we talked about a lot. And so this is providing a baseload power service, but then also a huge flexibility service. And altogether, it's a super package. It's like,
yeah,
virtual power plants are a whole nother super package that's way beyond what baseload power plants are. So it's not just like they're replacing them. They're doing much more than they ever did. So let's move on to what the U.S. Department of Energy and NREL are doing to accelerate the adoption of VPPs. Andrey, can you talk a bit about that as well?
Yeah, I think there is a lot of push especially in the recent years. I think recent couple of years. I think the research and the interest in virtual power plants in Department of Energy, DOE, and in national labs was before also quite visible, but I think recently there were a few funding opportunity announcements from DOE that explicitly encourage implementations of virtual power plants. I think that the technical aspects of virtual power plants, kind of the technology behind it, is quite mature already. So there was a lot of development in academia, national labs, in industry in the recent years that actually allow now to implement the virtual power plants. And we can see from the existing companies that are doing that. And I think DOE and the government, and specifically DOE, they really support him in that. They also provide a lot of funding recently. I think another thing I want to mention from DOE is that DOE recently encourages a lot actual deployments and demonstrations. So if you look what happened, 2-3 years ago, most of the research was focused on technology development. I think now there is a lot of focus and funding going towards actual demo projects, including virtual power plants. We at NREL, we were involved in a few demonstration projects so far, and I think there are quite a lot of in the pipe with our industry partners as well. I can definitely talk more about that, but I think I wanted to see what others think about how do they see. I mean, this is my side of things. That's what I see from the. I'm not part of the DOE, right? I'm national lab, but
yeah,
kind of
NREL people always say this. They're like, we're not
Right.
part of DOE.
No,
Like, well,
we are in
of,
between, but I think we see more closely what DOE is doing. But I think I was just curious what Ben and Jeremy.
I'll hand it over to them as well. But I just my sort of like news and blogging mentor, mostly not directly, was Joe Romm, who managed $1 million of DOE budget many years ago, and then started Climate Progress, ran Think Progress's Climate Progress blog for years, and he was adamant: deploy, deploy, deploy. It was about, like, enough with the R&D. I mean, not enough with it. I'm sorry. We need the R&D, but it's like deploy, 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 and you learn by deploying. And I mean, that mantra stuck with me. It's also his tremendous communication skills. You got to repeat, 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 deploy, deploy, deploy. And immediately what came to mind was from years ago, Joe Romm: deploy, deploy, deploy. So I think it's just very, it's great we're at that stage. It's fun to cover.
Now we are closer to that stage. I think years ago it was a bit rough. I mean, it was a bit extreme, I would say.
You need the early stages. You need, but you need the early stages. You need the R&D, but then at some point you have to just get out there and start doing it. So we're having more and more projects that are, really taking it to the next level. Ben,
and I wanted to point out just before, in this context, is the recent huge investment of, I don't know, billions of dollars in this IIJA, Infrastructure Investment and Jobs Act, and the Grid Resilience and Innovation Partnerships, GRIP, funding that recently DOE issued. And a lot of these projects, if you look into them, they also involve some elements of virtual power plants. So I just wanted to mention that.
Jeremy and Ben, do you have anything more to say on the DOE, how the DOE is working to accelerate adoption of VPPs?
Yeah, I mean, I think that the need for VPPs is large because of several of these macro trends that DOE sees, and also we in the private sector see. I'll just point out massive electrification of all sectors of our economy, probably led by electrifying transportation. Those projections are indicating a reversal of long-term trends of load decline. They're now leading to load escalation. And so how are we going to build out the infrastructure simply to keep the lights on I think is a challenge for all parts of the US economy, both in government and the private sector. And then of course, then we couple that with DOE and the federal administration's clean energy goals. And so not just how do we grow capacity, but make sure it's a higher and higher percentage of clean share. I think, so Jeremy and I are in the private sector. So I think for us, we see a strong role for Department of Energy and the federal government to, so I think the challenge is, as Andrey said, is less on the technical side. The technology exists, the generation technology, IT technology. I see it more as a coordination and alignment of market signals challenge. One of my favorite statistics, there's over 3,000 utilities in the United States. There's 7 independent power markets. There's whole sections of the US that aren't even in a power market. And so we just live in a world where there's a patchwork of regulations and policies and incentives and what individual DER owners are incentivized to do versus what utilities are incentivized to do by their public utility commissions, by their ratepayers. So I think that if we're really going to achieve these high-level goals of electrification and decarbonization, there does need to be some kind of alignment of all the disparate paths here. And so we hope the government has a role to play in that. And of course, we in the private sector, we're very ready to meet the challenge and provide our own help to meet that challenge.
Yeah, I think the only, again, not being a part of the DOE, I can speak just from an outsider looking in. I mean, what we're, obviously VPPs are important to DOE. They just recently released that Commercial Uplift document. That's definitely an interesting read for the audience to go and reference. Jigar Shah and his teams constantly are trying to promote and nudge the market and with investments into virtual power plant pilot projects. And I think, they're actively trying to encourage regional regulators and to start to realize and adopt some of the policies that will be needed to start to accelerate the adoption, such as FERC 2222, some of these other policies that are out there. So we definitely appreciate the DOE and the work that they're doing to help educate and promote virtual power plants.
Yeah, and I think my fact checking team is telling me I accidentally said million instead of billion for Joe Rom. Of course, he managed a big budget. $1 million is nothing, unless we're talking 1970s. But yeah, this is a great intro. Let's move on to how AI and machine learning are being utilized to enable virtual power plants. I think I don't know how much we need to talk about what AI and machine learning are. We know AI is all over the place. Machine learning, I don't know if you want to get into that, but how is that helping? We'll start with Ben to enable virtual power plants.
Right. So I think that it goes back to our premise of if you have millions of devices that are operating in concert, then you need a corresponding series of software to coordinate them, to be able to manage the information that's fed to them, how they react to that information, how they coordinate and adjust in real time. And you can also bring in the element of grid edge, where there may be latency concerns where there's not a possibility of coordinating with a central entity. So I think that we see ML and AI being used in a variety of ways. And I think to some extent, we don't know the full extent that machine learning will be used, but we see a few ways right now. I think one of the leading ways is just providing better predictive analytics. So being able to better forecast wind and solar generation in real time and in day ahead, as well as demand, market prices, if those are relevant, peak demands, that sort of thing. So those sorts of analytics are really just the inputs that are driving the operations of the virtual power plant. Then machine learning can be used in the optimization of the coordinated device. So how these devices are optimizing their control and dispatch to the market signals, both as a whole and individually. There is also a role for AI to play in real-time monitoring control. So enabling monitoring of the devices and controlling them in real time. Which device is actually being dispatched at any single moment? How do you coordinate that and make it work cohesively? And also resilient, as Andrey said, to potential changes in weather or other grid conditions. And then one of the final ways that comes to mind is just anomaly detection. So how do you detect anomalies on the grid? How do you escalate them and respond? So often these types of anomalies, they might be frequency related. So you really only have seconds to minutes, if that, to respond accordingly. So I'm sure Andrey has several other great ideas that's been cooking in his lab. So I'd like to hear what he has to add.
And I'll just interject that, I think, we talk a lot about vehicle to home, vehicle to grid, backup power systems connected to the grid, not connected to the grid. And it all just seems to make sense, like when on the surface. But then in reality, we have to see how it plays out. We have to see how many people end up with each of these, how many people deploy them regularly, how many people switch what they would normally do when there's a natural disaster emergency, where they might normally have some pattern of sending power back into the grid, where they decide, no, I'm going to keep that for myself and send it into my own system off the grid or whatever. So just, I think as the market evolves, we don't really know where it's going. So we have to see where it's going. And imagine the AI and the machine learning help you to map out different futures and also help you to try to understand what's happening as quickly as possible so that you can adapt as quickly as possible, right?
Yeah, absolutely.
Yeah, and I'm not sure. I mean, you're talking about a pretty small percentage of the general population that's going to want to even control these types of devices. I mean, I think the majority of users want it to be automated and optimized to make it easier. Ben's talking about millions of devices. You think about just an individual residential consumer who's got a smart home or an electric car, and even like a dozen devices, and trying to monitor when to and how to participate in different programs and when to engage and when not. I mean, that level of complexity and the time required to optimize it is more than most consumers are going to want to do. And that's really where AI and machine learning can come in and shine to be able to understand trends and predict events and to optimize it for individual consumers, as well as like business owners who want to be able to focus on what they do, their core business.
Yeah, it's a great point. I think we've had many discussions about wireless charging versus manual charging over the years, and all different topics where many times where the conversation ends is like convenience always wins on the market, like
Yeah.
like convenience and cheapness, you know. So I mean, as much as possible, market actors are going to choose convenience. So I think, like you said, some people will be loving managing their own system, but when we're talking about mass scale, not 0.1% of the market, but 50% of the market, then there's going to be a heavy trend probably towards letting someone else do it for you and just trusting that they do the best they can for you. But yeah, Andrey, do you want to say anything more on those topics? I'm sure you do. You must have to.
Well, I think you guys covered most of it. I just wanted to maybe summarize or emphasize this. So, you know, again, since we're talking about virtual power plants and we are contrasting them to regular power plants, right? So when we talk about control and optimization and operation of power plants, it's usually model-based. So you know very well the model, you know exactly what is going on, you know the outcomes of how the power plant will react to your control commands and all this stuff, right? Whereas in the virtual power plant, things are so much more diverse, chaotic, and there's a lot of inputs, a lot of uncertainty. That's why the AI and machine learning is a very good use case for that, right? Because you will learn from data, you will learn from the actual measurements how to operate the virtual power plant, essentially using these advanced machine learning algorithms or AI. And another element here that I want to emphasize, compared to power plants, virtual power plants also have human in the loop, right? There is a lot of human elements which affect the behavior or the performance of the virtual power plant, especially on the customer side. And again, this is in order kind of to optimize the operation of such systems with human in the loop. AI and ML are one of the best ways to do that. So yeah, just wanted to emphasize those. Yeah,
those comments like perfectly lead into the next question, which is like from a practical standpoint, how does a VPP function and who is running it? So when we talk about it, it's all just like a simple concept, but who's actually running it? How does it function? How does it get done? I think Ben is the best person to answer that question, or?
Yeah, I mean, I think that there's not really one answer right now, Zach, and I think that speaks to one of the themes that we've been bringing up, that there is this broad landscape of solutions, providers, stakeholders. So I think there's many ways to cut the cake, basically. But if we think about it, I would also distinguish between how a VPP is operated in a market or a non-market region. So, you know, as we said earlier, essentially a virtual power plant is the aggregation of many smaller resources that are acting in concert as a single power plant. So how that power plant operates varies based on its geography. It might be commissioned just to provide a subset of its possible services. Maybe it's just dispatch to provide reliability or frequency or something. That's definitely some of the outcomes we see. But in their full sort of glory, you know, VPPs can participate in energy markets. They can provide capacity services. They can provide ancillary services, and you know, just to enumerate some of those, they can reduce peak demand. They can be load following. They can regulate frequency. They can provide even black start services as needed. So I think that operationally, you know, they operate by aggregating the capabilities of the individual assets. Different technologies are capable of providing different services. Not every DER can provide every service. So you have to consider how it's composed and the diversity of those resources. But then each device is being monitored in real time and being dispatched in response to the market or the grid or the operator signals. Behind the curtain, there's almost always some manager of the virtual power plant. So that manager could be an electric utility. It could be like a market platform. So GridBeyond is one of those such market platforms. It could also be a technology provider, say Tesla, that manufactures electric vehicles. They can also operate virtual power plants on their behalf. And then I think there's also, you know, this stakeholder kind of layer to it all, where you do have to continue to collaborate and remain cohesive among, you know, who are actually the owners of those DERs. Is the virtual power plant acting for their benefit? Does the juice justify the squeeze, if you will? So how are they being remunerated? How are they being alerted of potential dispatch of their resources? What are the types of opt-in or opt-out policies? But then even larger, what are the appropriate regulatory codes? There are some areas where virtual power plants aren't encouraged or aren't allowed. So there's sort of this constant evolving fabric of policy, of individual asset owners, of utilities, of grid services. But yeah, from a practical point, I think that's how you can understand how a VPP functions.
Very cool. And we actually had a viewer answered our pop quiz question earlier. Craig McBurney writes, the concept of virtual power plants was firstly introduced in 1997 by Dr. Shimon Auerbach, with the term virtual utility. So almost the same, proposing the creation of small systems capable of taking advantage of the benefits of distributed energy resources, DERs. So there's our answer, it seems, and it sort of leads into the, returning to the question, like, what are the benefits of VPPs? Can we talk a little bit more about those benefits? Because we sort of touched on them here and there, but maybe let's get a packaged answer from Jeremy. Can you take that on?
Yeah, thanks, Zach. I'm glad you didn't press me for an answer on that. I was just going to guess Taylor Swift. So, but when we think about the benefits, we touched on resiliency, and we also talked about grid balancing, which I do think we should double click on those a little bit further. But in my mind, affordability is such a key benefit of virtual power plants. We think about on the residential side, consumer side, there's estimated 20 million Americans who are behind on their utility bills. Energy bills are one of the biggest costs facing a lot of middle to low income households. Virtual power plants can help enable and adjust energy transition by making distributed energy resources like solar, home batteries, electric vehicles more affordable by lowering the cost, creating revenue that you could put towards those assets, and then reducing the total cost of ownership by lowering your utility bills. So I think when the DOE, I do think is really high on this point, looking for opportunities to incentivize through the Inflation Reduction Act investment in distributed energy resources in low income disadvantaged areas. And I think it's a challenge to all of us in the industry to look to opportunities to build out infrastructure to help utilize virtual power plants to generate revenue by market participation or demand response participation to lower the energy costs, lower the utility bill cost for consumers, which could be a big impact in helping improving the lives of those consumers that would be impacted. Not to mention the health benefits. If you're moving away from traditional energy resources to more distributed energy resources with less fossil fuel participation, improving air quality, or the resiliency issue. If you're dealing with brownouts, blackouts, we're going to be facing more disruptive weather events as we move forward into the future. And if you have a virtual power plant capability with microgrids, you can set up resiliency zones that could benefit those residential consumers. So that's kind of the residential side and affordability. But then on the commercial and industrial side, those businesses that have set decarbonization goals and they're struggling to make progress towards these goals, oftentimes that's based off of ROI issues or CapEx issues and how to monetize these DER investments. Virtual power plants create an opportunity for them to do that. Basically monetize DER assets. If you invest in solar and you invest in battery and EV charging infrastructure at your business location, you can then opt in to participate in a virtual power plant program to get money back, and you could utilize those funds to apply those to either investing in additional DER assets or potentially or lowering your operational costs. So I think when you think about C&I and residential, those two benefits I think are really important.
Very good. Yeah, my older daughter is obsessed with Taylor Swift. I'm sure if I asked her the question the right way, like who do you think came up with the term virtual power plants, she'd answer Taylor Swift. So this is a good guess these days for anything.
Now, You guys have to be careful, otherwise ChatGPT is going to start answering that way too.
Yeah, I was going to bring up ChatGPT earlier with you, but I thought the time passed. But yeah, do you guys have anything to add on benefits of? I mean, Jeremy covered a lot there. Anything that you wanted to chime in with as well, or did he cover everything?
Well, I think that just, I think a fundamental tenet of the power system is just the peak demand problem, right? So the entirety of our electrical grid, simplifying a little bit, is essentially built out to meet the top 1, 2, 3, 4 hours of peak demand in the year. And so most of the time the grid is not stressed. Most of the time costs are containable, but we still need to build out the capacity to meet peak demand and then some. So I think that similarly, costs follow a kind of exponential process there as well, where anything that we can do to reduce peak demand has much higher marginal benefit than, reducing demand for the median hour. And there's also a parallel process there of decarbonization. So it's much easier to decarbonize the first 50% of power consumption than it is the last 5%. So I think that any kind of innovative solution that we could do to shave peak demand or marginally reduce carbon around the edges has enormous benefits just by virtue of the peak demand problem.
Can I ask too if it has any potential role that you could talk about in peak supply, or the duck curve as they call it, the issue of so much solar power getting generated in the middle of the day that it's a bit too much at times? Do you see a role for virtual power plants in helping with that as well?
Andrey, do you want to take that one?
Yeah, I think it's one of the goals, right, of the virtual power plants is to deal with situations like overproduction of solar or wind or general renewable energy sources. And if you do it in a concerted way, as Ben was describing before, these virtual power plants, it's like a concerted effort to coordinate all these resources. Eventually, you would save the instead of kind of just curtailing the energy when you don't need it, you will just save it and shift the demand or the production to the other periods where you need it. So essentially, it's part of the package, right, of this virtual power plant, is to make sure that you don't overproduce when there's too much renewables, and you save the energy for the other periods where you need it. I think that's.
Then maybe we can move on. What do you see as the big challenges or barriers to overcome in this space to deploy VPPs more and better? Jeremy, back to you.
Yeah, and we'll definitely want to get Andrey and Ben input here. But when you think about the adoption of VPPs, I think it's a lack of kind of standardization, a lack of regulatory certainty. There's not like one program or one platform to utilize. It's disparate. Utilities have different programs. I think the question that came up with the recent reference that DOE Uplift report, they listed out some of the barriers, and one of the solutions they suggested, which I think is very interesting, is like having DER assets come, already opted in to participate in these programs. That would give you the option as an individual, as the owner of that DER asset, the option to opt out. I think that could be a critical kind of a market kind of VPP design mechanism that could really help accelerate the adoption. And I've struggled with this personally. So, I mean, I have the Ford Lightning truck, which is bidirectional, and, and I'm passionate about the energy transition. I've got solar and the incentive to come in and I would like to participate, but there's complexities that are hard to understand. First, I've got to get a charging station that will enable it. And then I've got to be able to monitor with PG&E, like what programs am I eligible for and when do I participate? And that's not really clear right now. So I think, getting those programs standardized and making it easy for owners to participate. Like if I buy the Ford Lightning, it should come enabled. And when I get home, PG&E and Ford would coordinate to make sure that that I'd be able to be fully integrated and I'm opted into the PG&E local virtual power plant program, and then it'd be out of sight, out of mind for me. Every now and then I might get my utility bill. I'm like, oh great, you know, I'd look at this, I saved some money here, my bill's lower this month. That's very exciting. And that would be all that would be required of an individual. Like right now, there's a lot that's required for me to get those assets set up.
Yeah, no, it's a huge difference across all programs. If you're automatically opted out and you have to opt in, or if you're automatically opted in and you have the option to opt out, you get vastly higher participation if it's, you know, automatically opted in. And of course, if you're buying a Ford Lightning, you know, I mean, and it's got that capability, more likely than not, you'd like to save money using it. You'd like to participate, and it's not that hard, you know, not that hard to have the system you know, clear that if you don't want to be involved, you can opt out. You know, that's not difficult. So I think that's a great point. Yeah, anyone else want to chime in on barriers to overcome with markets, regulations, or technical complexity even?
Well, I think you know, it's interesting question here about how do we best encourage consumers to participate in VPPs or to participate in any variety of, you know, grid programs. So I think that you know, we can kind of break that into a few ways that we traditionally incentivize. So we can say, oh, we're going to design retail rates that incentivize consumers to follow, you know, time of use patterns, and that has had success, but it's also had limitations. Then there's more of like the normative approach to say, you know, you should turn off your lights because that saves the planet, or you will save 2 cents on your electricity bill. And again, I think that has definitely value, but also limitations about people act normatively, but there's a limitation. I've personally always been more of a technologist. I think that the solution to a lot of these problems is to unlock technology to simplify my decision making, to automate it. You know, going back to Jeremy's example, like I'm not sure, Jeremy, if it incentivizes you to save 37 cents on your electricity bill to have your lightning charge at midnight instead of, you know, 7 p.m. And that's a fictitious example. But I do think that matters to you if it's, you know, 37 cents multiplied thousands of times over the year in a way that you personally are not capable of acting in that way. I also think there's
where you're not getting pinged all the time. Do you want to charge?
Yeah,
them? Do you want to
right. And there's a wide gulf between like the amount of benefit that would incentivize Jeremy to charge his Ford Lightning versus what actually matters in the grid. I mean, there's just a 10x difference between the amount of money that's needed to nudge consumers to act differently versus what incentivizes resources in a wholesale market to act differently. So, you know, just to go back to the top, I think I agree with Jeremy. I think that the technology is there. I think the will is there. We are seeing a lot of technology developments, market developments, but I think it's ultimately a matter of coordination, standardization. You know, FERC 2222 really opened up the floodgates of this kind of discussion, and FERC 2222 needs to be fully enacted in all of the relevant market areas. It needs to be enacted in a way that allows consumers and market actors to realize the premise of that order.
Good stuff. We have a number of questions from viewers here, so let's just jump into these a bit. Frank Fruby asks, how can VPPs improve reliability by reducing demand peaks during dark calms? What is the process by which demand can be reduced? Andrey, you want to take that on a bit?
So can you repeat the question? Sorry,
or anybody can chime in. Can you see the questions as well, or only hear me reading them? How can VPPs, you got it, Jeremy?
Yeah, I can jump in. I mean, I think VPPs can definitely help here. I think this is one of the key value propositions of virtual power plants. Is going to be able to, when grid operators and utilities are dealing with an inadequate supply or some reliability issue with the grid, they can send signals to virtual power plant participants with incentives to participate, to either reduce demand or automatically reduce demand from participating devices. I think that's really where the technology is going to benefit, you know, grid resiliency and reliability, especially once it gets at scale. When you think about the electrification of everything, you know, there could be a burden, for example, on an individual electric vehicle owner to get a signal saying, hey, if you pull over and plug into the grid right now, you can make, you've got maybe a predetermined strike price to get a signal to your car. Maybe you're an Uber driver and you get this signal to pull over and plug your charge in. Plug your charge in. That's a viable mechanism that's we'll probably see in the future. But less disruptive is going to be slight demand response participation, where you send a signal to participating devices. Maybe it's an HVAC, could be other smart devices where you just adjust the temperature on the air conditioner in a building, maybe a couple degrees, or you turn a certain number of lights off in a commercial setting at a grocery store, and that's all pre-agreed and pre-set up. Where it's automated and out of mind, but over millions of stores within that region, it would give the grid the reduction to help address that peak demand moment.
And we've talked about this a little bit, but not really explicitly. Craig McBurney asked, what generally are various utilities' positions on VPPs? It's a good question. It's especially their relationship with solar has been complicated over the years. Who wants to?
I can't see everybody else, but I just answered one. Ben or Andre, why don't you guys go?
Well, I think it's difficult.
Jump.
Yeah, I mean, I'm not sure I'm going to speak for all utilities. I think it is a mixed bag.
Yeah,
I think some.
Well, one of the things to think about here, the utility, in California, the Public Utility Commission just did a study recently looking at, how are the big investor-owned utilities in California going to address this massive new load that's coming. I think between 2023 and 2030, we're looking at like 200 gigawatts of additional load coming to the grid nationally. It's a huge amount of new load coming in, and they estimated that, I don't remember the exact number, I think it was something like $8 billion between the big four utilities to build out the grid infrastructure that would be needed just to accommodate this coming load. So they have an incentive, and I think FERC 2222, like Ben mentioned it, which is, again, just real quick, that's the FERC order 2222 basically grants the same rights and benefits to DER owners that a utility would get, the same incentives. And that's an important order that's been put out by FERC. And so once that gets implemented, you're going to have more incentives for, I think utilities are watching this happen. But there's complexity on their side too that they've got to deal with. How are they going to settle with customers that are participating in VPPs? Is it going to require digital, programs or softwares or blockchain technologies? So they have a lot in front of the utilities are facing. And not all utilities are equal. Some of them are more progressive in adopting this. Some are lagging behind. But there's definitely this sure incentive. Otherwise, they're going to be giving up this ground where they've traditionally provided grid as a service to individual owners. So I think you'll start to see, and we're already seeing this, utilities become more aggressive at offering VPP technologies and platforms to their customers.
We also have another answer from Craig. He says opt-in dynamic pricing would save 3 times, I think, as much virtual power plants, according to a study by PNNL. I don't know if we're allowed to mention PNNL with NREL guy on the call, but no, of course you cooperate a lot with that laboratory as well. 10 billion versus 30 billion. So yeah, just more to back up that opt-in advantage. We have a question here that we just sort of touched on, but it's more explicit. What is the role of the battery electric vehicle owner for VPPs, and what does he benefit in the participation of to VPPs? So just excluding solar, excluding energy storage outside of a car, what's the role of a BEV owner?
Yeah, maybe I can start here to answer. So the battery electric vehicle owner for the VPP purpose is a moving battery, right? It could provide both positive and negative service. In a sense, it could charge if the battery is bidirectional, if the EV is bidirectional, as was mentioned before. It could be both storing energy and producing energy, right, at strategic moments based on the mechanisms of a VPP. So essentially, for the VPP, this is just a battery that could be used as one of the distributed energy resources. So, but I guess the question was about what is the benefit to the owner of the electric vehicle? Is that the question, right? So I think, yeah, the battery, the owner would benefit basically if the VPP is implemented in the correct way. The owner will not feel any service degradation on one hand, right? So it would just have their vehicle charged, and everything would be fine from the customer perspective, but it would probably get some benefits from saving money on the electricity bill, because as was mentioned before, the charging will be performed at the times when it's not too expensive or it's not stressful for the grid. But kind of in terms of the satisfaction of the customer will be satisfied, and the grid will be not stressed by this charging at times where it's not where it's stressed. So.
And we have a long one here, but I'd like to try to get to it. I like Benjamin's comment from Bill Outhouse. I like Benjamin's comment about democratization. The prosumer makes the investment in DERs on a VPP. What third party M&V or of distributed energy resource value can the prosumer cite before negotiating with the VPP aggregator for fair compensation? He goes on, investor-owned utilities want to charge an exit fee, and for-profit VPP aggregators say the extent of distributed energy resource value capture is an industrial secret. Could a VPP be a prosumer-owned cooperative, like an agricultural producer cooperative, to represent the value of their investments?
Yeah, it's really, really interesting comment, Bill. I think that that's a whole part of this, the customer advocate, right? So in the same way that we have advocates or other entities that aggregate the interests of consumers, I think we also need to think about this to make sure that there is an equitable distribution of benefits between the consumer, between the manager, between the utility, between all the parties involved. I think a cooperative, an agricultural cooperative, or any kind of municipal or cooperative utility could certainly be an organizer or manager of a VPP. I think just with the caveat that there is still a high technical barrier to managing and operating them in real time. So to the extent that it's hard for me to see an agricultural cooperative having that level of technology sophistication. Of course, maybe there are software solutions that allow them to represent the interests of their members. Yeah, absolutely. This is one of the premises, is that there's many ways to organize the different stakeholders.
Anyone else want to chime in on that one? It's quite a interesting, never really seen that brought up like that. So also, we're having a webinar. We are a media company. We do communications of various sorts. The question here from Frank Hruby is, how can we best educate the public about distributed energy resources and virtual power plants, and why a household or business should electrify and should install systems that can interconnect with the virtual power plant? So what are we're having a webinar, that's obviously one approach, but more broadly, what are some other, how do we educate the general public about this? Do we need to, maybe I also feel like Germany might say we just need to get it in place and have it automated so they don't have to think about it. But
that goes back to your deploy kind of comment. I think really where this comes down to is ease of use, and that's where I love the opt-in option, and then dollars. If you get, if you get incentives to participate in rewards in the form of dollars, and I think that's all the education that's needed. I will say, for those consumers that are interested in getting more educated, the visualization, being able to visualize a virtual power plant, which is something Ben and his team do real well, where you can actually see through, for example, with an electric vehicle fleet, where you can see where the vehicles are, where market prices are in real time, and where they're projected to be later. And then you can actually then see these them dispatching power into the grid or charging batteries, and being able to visualize it, I think really brought it home for me and helped me better understand the concept. And it seems so complex and so difficult to implement, but I think that's really where the amazing power of AI, machine learning, and software come together to make this disparate, complicated kind of system become very easy. Hopefully that helped answer the question.
Yeah.
Yeah.
You want to say something, Andrey, or?
Yeah, I just wanted also to maybe in connection to this question, I think it is important also, well, when we talk about educate people about DERs and VPP, I think another related question is how do you make this technology affordable to different population, right? I mean, right now, if you think about it, DERs and VPP are really for people that can afford it, right? And if we are not thinking about how to make this technology affordable to larger types of populations or like different types of populations, this technology will not be widespread eventually, right? And that's one thing that I think is very important. It's kind of a question that is out of my scope, definitely, but I'm always thinking about it because technically I can implement whatever virtual power plant you want, but if it's not supported by the actual people that can afford this technology, that's a problem.
The big one.
That's a great point, Andrey. And I think it maybe goes back to a little bit of that question. I think it was Bill was the audience member name that asked the question to Ben. I do see, you can kind of see the future where maybe a developer of a low income or development, say neighborhood or a multi-tenant complex, in order to get that building permitted, they are commonly now, like here in California, any new construction has to come with solar to power or renewable energy to power that facility. Maybe in order to get those buildings permitted, they're going to be required to have an opt-in VPP option for all the, those tenants that would come in to rent from those facilities with pre-negotiated terms and conditions that make it very easy for lower income consumers to benefit from this technology, and that would be very easy to do. They would move in, your thermostat gets controlled, or you get an incentive from your local, utility to get a rebate on an electric vehicle. Those types of programs and that technology and economics are there. It's just a matter of setting up policies. And I think that's a trickle down. That's probably stage 3 from where Ben was talking. We need to get market clarity and set up. We need to get regulatory programs set up. And then I think you'll see innovative, more sustainable, focused initiatives to help expand the benefits to those who can't afford it today.
Yeah, well, this is great stuff. We are at time, so just, is there anything we missed? Anything you want to end with? Any final comments before we close out? Everybody's good. We talked a lot. We covered a lot of ground. I mean, starting to think we covered everything possible, but I'm sure there's much more. But yeah, it was great discussion on virtual power plants. I think right at the end there too, Andrey, sort of opening the door to how much more you could discuss with them and how much more there is to figure out. But thank you to everyone for listening, for joining, for watching, and yeah, check in next time.
Thank you.
Thank you very much.
Appreciate the opportunity.
Thank you.
Bye.